Hi, today I'm going to make a tutorial video for 3D scanning this object. It's the air filter box of my car. It's about 1.6 millimeter in thickness. And I will scan both outer shell and the inner shell. And I will use the Scan Raptor Pro for making this 3D scan. So it's recommend that when you first got it, you should calibrate the scanner because it has been put into vibration and impact during shipping. And in the bottom of the box, you see this calibration plate. It's made from glass. This will use for correcting the accuracy of your 3D scanner. When you comparing the measurement of the 3D scanner with a reliable measuring tool like a vernier caliper or micrometer, it should be in the range of somewhere around under 50 microns. This calibration board cannot improve the precision of the 3D scanner, it's only accuracy. If you flip to the back of the board, you will see that it has QR code and a serial number. This board is made to be paired with your scanner, so if it breaks or you lose it, you cannot use the replacement calibration board to calibrate the 3D scanner. So if you break it, I'm not sure if the Creality can supply you with the new calibration board. Okay, when you come to the home page of the Creality Scan software, there's a button here. When you click in there, then you click on the Start Calibration button in the bottom here. There's a checkbox that scan QR code. If you never calibrated this before, it will ask you to scan a QR code, start calibration. It will use the RGB camera to read the QR code in the back. After that, it will enter the calibration mode. Look at the screen here and then you orient the calibration board to be in the same orientation as shown in the monitor. There is no arrow here. In Raptor X, it has a small arrow where it's the up direction. So this one has no arrow, but you need to align the larger dots to the same alignment on the screen. Okay, so you have 22 lines and 7 lines. So it will make 2 calibrations, and each calibration will have 5 movements. So you need to make 10 movements in total to complete the calibration. They have like a water bubble meter on the screen so that you can align the scanner. First, you put it into optimum distance. Don't place your scanner too close to the board. And then if you see the orange color on the screen, move your scanner to the opposite direction. So if it's in the orange, it means that I lean too much toward the front. So I will lean it back just a bit and the orange color will disappear. And then I can start moving. If you ask you to move to the second orientation, you need to back off a bit. Don't put it too close. Yeah, it's better to look on the monitor, not your hands. Okay, now I'm entering the 7-line laser mode. Okay. Just make sure that there's no orange color. And then start moving after the orange color is gone. There's no orange color, then start moving. So this is done. Wait for it to process the data. Now I get 98.2 scores. You need to be careful when you keep it. Put it in a original plastic bag so you won't scratch the markers here, and when you store it, face it down like this so the sticker marker won't be easily scratched if there is some accident. I plan to make a 3D scan by using the markers applying directly onto the surface of the object, and then I will scan from outside to the inside in one single scan without merging, because merging could be difficult for this kind of object because it has a very thin wall and it has a parallel surface. Okay, first step I will apply the sticker marker. There's two sizes, 6mm and 3mm. They are both reflective markers. I think they give you like 20 sheets. I personally bought it from AliExpress. It's cheaper than the Creality store. Usually the spacing of the marker for 22 lines mode is about 10 centimeters. So if I stretch my finger like this, it will be about the length of my finger. So in the place with a small radius, like in the top here, I will use a 3mm sticker because the bigger one will it will bend. For the curved surface, I will use a small one. There's an area, a gap between these two surfaces, and the scanner won't be able to scan it. It blocks the protection of the laser beam. So I need to repair it with the third-party software. If you have a software that you can use for repairing the model, it would be benefits. You don't have to use CAD software to reverse. To reverse this, it would take me 2 hours with the Autodesk Inventor. If you have a clay repairing software like Substance 3D Modeler, then you can repair it in less than 30 minutes. I put more markers than I need to because I want to be able to track from outside to the inside of the shell. I will scan the overall object with the resolution 0.3mm. You don't need a highest resolution to scan the object. It won't give the best mesh result. 0.3, I will get somewhere around 2.5 million points for this object, which is more than enough because there is no intricate detail to scan with a high resolution except this part. It has a very small ellipse here. And I will scan this part with 0.15mm resolution. So I will use 7 lines to scan this area. So I will add a little bit more of the marker in this location so that the scanner can track. Looks like we have enough of the markers. Okay, this is a deep pocket. The surface of the plastic is kind of shiny. For the outer shell, it's fine to scan with the Raptor Pro without spraying. But for the inner shell, I need to spray it. If I don't spray, have a reflection inside of this small cavity, and it will be very slow to capture. So I will spray just the inside. Okay, so I have already sprayed inside of the airbox. When you come into this menu, you need to choose the real-time resolution. This will reflect the resolution of your scan. For the object this size, I will pick 0.3 because the geometry of this object is not going to change within the 0.3mm. It's just a flat area. Most of them is a flat area. If you are going to scan a coin, you probably can use 0.1mm, and if you're going to scan a car panel, you should go for 0.6, and if you are going to scan a whole car, you're going to use 1.2 or 1.5mm, because the change in the geometry of the surface of the object is really low. I can scan this in the highest definition with just 0.4mm. This clip has a very small stiffener here. I will use 0.15 to scan for just this area, and for the whole object I will use 0.3. Next, I will use the global marker. Global marker will scan all the markers and it will optimize for smooth scanning. When it sees all the markers, it can predict which is the next marker it's going to see. So it will scan faster if you use the global marker. When you use global marker, you see here there's the exposure adjustment button here. This button will adjust the exposure of the infrared camera, which will detect the marker. See here, it's quite dim. I'm gonna increase the brightness just a bit. Now it's brighter. Okay, it's bright enough. If you are scanning in the outdoor, we probably need to turn down the exposure for the marker. Okay, I start scanning. So on the upper right corner, you will see that it has the number of the markers. Now I have 57 markers scanned, and the location is registered. So here, let's move fast. See here, it's fast because it uses a graphic card, NVIDIA graphic card. The next, I'm going to flip it up and make a scan on the inside. Slowly move. I'm not using the external marker. Everything is attached to the object, so I think I put about 100 markers here. So I'm going to less it up a bit so that it will be easy for me to delete the turntable. Okay, I will continue with the point cloud scanning. I click on the point cloud, click yes. Okay, now we are in scanning mode. And this exposure button will turn to laser exposure control. Okay, I'm going to switch to 7 lines mode to scan some area here. It's easier to capture with the 7 line mode, especially the finale area. So I'm gonna double click play and pause button to make a 3D scan in 7 line mode. Because I'm trying to get most of the surface area as much as possible. I'm going to 3D scan this clip here with the local detail function. Click on local detail. It has a resolution for you to pick up from 0.05 to 0.15. I'm going to choose 0.15. And you're going to need to use the mouse and the keyboard. Select the area that you want this higher detail and then click on apply. It will delete the point cloud. See, it's gone, the point cloud, and it will tell the scanner to rescan with the 0.15 resolution for just that area. So you have now it will start scanning. You see that? The deleted area will be filled with the 0.15 millimeter resolution, so it's a high detail area. Okay, I'm picking it up and I'm going to scan all the sides. Next, I'm gonna scan the inside, but first I need to delete the table first because it's in the way. So I will stop the scan, delete the table, and then come back and rescan it. I delete the table, delete the point clouds. I click on the continuous scanning. I'm trying to make it easy for me to delete it. So I'm gonna raise it up. So it's still in local detail. I'm going to choose the point cloud and cross line. Okay, I'm switching to 7 lines. So I'm going to delete the table. Okay, complete the scanning. Okay, I will delete it here. It's easier if you lace it up a bit from the table. You can select the table and delete it. Okay, I try to scan the rest of the airbox. I click on continuous scanning. It's erased from the table. I switch to the 34 lines. I can't scan the gap here. It's too narrow for the projector to get it through there. So I need to repair this part. And while optimizing the point cloud, we use both the CPU and the GPU. Not much of the GPU, but mostly it's the CPU. Okay, let's mesh the scan. 2.6 million. Okay, here's the result. We have 2.7 million meshes. See, the holes here is so I have to repair it. I give it 90%, so I will do some repair. So I remesh again, but this time I'm not using the hole filling function because I will use substand modular to fill the holes. Okay, let's move to substand modular. Okay, here is the scanning result after repairing. Is 90%, not 100% from the original object. For this kind of object, I still prefer to reverse it in CAD software because the object has a very thin wall, 1.6 millimeter. If you want to print this, even with the nylon SLS, you won't be able to print it because it's too thin. The only way is that you need to reverse in CAD and increase the wall thickness to be able to actually print this one. And when you look from the inside of the box, the result surprised me. I didn't think that it will be able to scan into the pocket this deep with the help of the spray. Thin stiffener is also scanned and captured very well. The wall thickness of this box is only 1.6 millimeter. The inside of the box is almost as good as the outside scan. The small clip scan with a 0.15 millimeters. I get all the detail of the stiffener, so you don't have to make a 3D scan of the overall object with a high resolution. You probably hit the frame limit before you can finish the scan. I use 0.3, but I think 0.35 would be ideal for this this object because it has internal and external wall, so it's quite a large scan area. 0.35 will be ideal, and 0.15 for intricate details area. With a deep pocket like this, I think CR Scan Author would be able to scan to the bottom of the pocket, but the blue line laser has a limitation that it won't go very deep. The 7 lines can scan better with a thin finale. 7 lines can do better than 22 lines, so you will need to switch between 22 and 7 lines to get a perfect scan. This box, I can say that the original designer has put a lot of work into it. This flank here will face with the rubber seal of the air filter. They have a small angle that it will match the air filter. So if you reverse this one without looking at the details here, the air will leak because it won't match the rubber seals of the air filter, and they use minimum materials. It's very robust design. I can say that the designer of this box is very professional. This is a highly engineered piece of design for economy, robust and function. Okay, thanks you guys for watching. I'll see you in the next video.